question. Today we will discuss what is telescopic series. Okay, a telescopic series is a series sigma k equal to 1 to infinity uk, where uk can be written as tk minus tk plus 1. That means for some series for some series tk. So what is a telescopic series? Telescopic series is a series uk where its term uk can be written as tk minus tk plus 1. For example, let's give you an example. Let sigma k equal to 1 to infinity 1 by k into k plus 1. So here uk is equal to, actually uk is equal to 1 by k into k plus 1, right? But this uk can be written as, if you take a partial fraction, a by k plus b by k plus 1. Okay, so which implies 1 equal to, if you cross multiply, a into k plus 1 plus b into k. So what we done is, we are cross multiplying this and this, and we are equating the numerator. Now put k equal to 0, then we get 1 in equation. I'm calling this equation number 1. So I'm putting k equal to 0 in this equation, then 1 equal to a. So a, k is 0, so b k becomes 0, so 1 equal to a. Now put, and so I got the value of x. Now put k equal to minus 1. So what will happen in equation number 1, which implies 1 equal to a into minus 1 plus 1 0, b into minus 1 minus b. So which implies b equal to minus 1. So here therefore 1 by k into k plus 1 can be written as 1 by k minus 1 by k plus 1. So this can be written as so here this is uk, so this can be written as tk minus tk plus 1. So this is a example for telescopic series. So why this telescopic series is useful? Because we can easily find the sum of the telescopic series. Okay, so we can cancel out all terms. So for example, so therefore by this is k equal to 1 to infinity 1 by k into k plus 1. So this can be written as, if I give k equal to 1, then 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus etc. So we want to find some. Now if I change this in this format, so this is actually equal to sigma k equal to 1 to infinity 1 by k minus 1 by k plus 1. Okay, so this is actually equal to, because this term is equal to this, so this series is actually equal to 1 by k minus 1 by k plus 1. So this I can written as 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus etc. plus 1 by k minus 1 by k plus 1 plus etc. So if I take nth partial sum Sn here, so sorry, if I take S1, we know that yesterday I told you that a series converges if and only if it's a partial sequence of partial sums converges. So here S1 is first partial sum, first term. So first term is this 1 by 1 minus 1 by 2. S2 is equal to S1 plus this term 1 by 2 minus 1 by 3. So this is actually is equal to 1 minus 1 by 2 plus 1 by 2 minus 1 by 2. So this is actually is equal to 1 minus 1 by 3. Okay. So now S3 is equal to actually S2 plus third term 1 by 3 minus 1 by 4. So this is actually is equal to S2 is 1 minus 1 by 3 plus 1 by 3 minus 1 by 4. So this is actually is equal to 1 minus 1 by 4. So in general, look at this is a pattern Sn. When n equal to 1, we get 1 by 1 minus 1 by 2. When n equal to 2, we get 1 minus 1 by 3. And n equal to 3, we get 1 minus 1 by 4. Therefore, what will be Sn? This will be equal to 1 minus 1 by n plus. So the sequence of partial sum is 1 minus 1 by n plus 1. Okay. Therefore, we know that what is the sum of the series here. Here, the series converges if and only if sequence of partial sum converges, right? This sequence. Therefore, you find the limit of Sn. Sn is equal to limit n tends to infinity. Okay, so n tends to infinity 1 minus 1 by n plus 1. So this is equal to 1 minus limit n tends to infinity 1 by n plus 1. So we can find the sum of the series by using uh, when we got a telescopic series. Okay. So we know that so what we done is for a telescopic series, look at here. So we got a telescopic series, that means 1 by k into k plus 1. This can be written as 1 by k minus 1 by k plus 1. So that is then we can write this series in this format. Okay. So we know that a series converges, sigma uk converges, or it has a finite sum if and only if its sequence of partial sum Sn converges. So we know that sequence converges if its limit Sn is finite. So here we took a sequence of partial sums, and our sequence of partial sum Sn is of the form 1 minus 1 by n plus 1 equal to 1. So now I will give you a problem. So next problem, same problem. So find the sum of the series sigma k equal to 1 to infinity 1 by k plus 3 into k plus 4. Okay, so actually this series is of the form 1 by K is 1, then 4 into 5 plus 1 by 5 into 6 plus 1 by 6 into 7 plus etc. Sometimes the question might be like find the sum of series 1 by 4 into 5 plus 1 by 5 into 6 plus etc. So if you got such a problem, then you convert it in this form. Okay. So now solution. So what is the step? So we know that this is actually this is equal to a telescopic series. So first step is we want to uh, convert it in the sequence of partials. So 1 by k plus, so here uk is equal to 1 by k plus 3 into k plus 4. This you can written as a by k plus 3 plus b by k plus 4. So which implies 1 by k plus 3 into k plus 4 is equal to a into k plus 4 plus m cross multiplying, okay, b into k plus 3 divided by k plus 3 into k plus 4. Okay, so now which implies, okay, so therefore denominator of both sides are equal, therefore numerator must be, and this two are equal, therefore numerator must be equal, therefore 1 equal to a into k plus 4 plus b into k plus 3. So I'm calling this equation number 1. Now we want to find out a and b. So put k equal to minus 3 in equation number 1. We get 1 equal to a, right? A plus k is minus 3, 3 minus 3 plus 4 is 1. K is minus 3, then minus 3 plus 3, 0. Similarly, put k equal to minus 4 in equation number 1. We get 1 equal to, if I put minus 4 here, 0 plus minus 4, therefore minus b, which implies b equal to minus 1. Therefore, our uk, therefore uk is equal to 1 by k plus 3 into k plus 4 can be written as 1 by k plus 3 minus 1 by k plus 4. Okay. So therefore our series sigma k equal to 1 to infinity 1 by k plus 3 into k plus 4. This can be written as k equal to 1 to infinity. You can rewrite this 1 by k plus 3 minus 1 by k plus 4. So this is equal to, so k equal to 1, you will get 1 by 4 minus 1 by 5 plus 1 by 5 minus 1 by 6 plus 1 by 6 minus 1 by 7 plus etc. So now I will take then the sequence of partial sums is partial sums Sn is Sn is equal to, you know that Sn is actually equal to u1 plus u2 plus etc. un. That means sum of these n terms. So that is actually equal to 1 by 4 minus 1 by 5 plus 1 by 5 minus 1 by 6 plus 1 by 6 minus 1 by 7 plus etc. plus 1 by n minus 1 by n plus 1. Okay. So that is Sn. Now, so this all things get cancelled. Okay, so the remaining portion only is equal to 1 by 4 minus 1 by n plus 1. So Sn is equal to, therefore the sequence of partial sums Sn is equal to sequence 1 by 4 minus 1 by n plus 1. Now we know that sigma k equal to 1 to n 1 to infinity uk converges if and only if the sequence of partial sums converges. Sequence of partial sum Sn converges. And we know that when a sequence is convergent when it has a finite limit. Therefore, we are taking limit n tends to infinity Sn is equal to limit n tends to infinity 1 by 4 minus 1 by n plus 1 is equal to limit n tends to infinity 1 by 4 is 1 by 4 minus limit n tends to infinity 1 by n plus 1. So this term goes to 0. Therefore, 1 by 4 is the sum. Thus sum of series sigma k equal to 1 to infinity 1 by k plus 3 into k plus 4 is equal to 1 by 4. Okay. So this is all about telescopic series, and I will give you a question. So you just practice this problem. So okay, not this. Find the sum of. Write down a problem. Find the sum of the series. Write down k equal to 1 to infinity 1 by 9k square plus 3k minus 2. So you find out the sum.